Hi my friends. Today we continue our discussion about finite element analysis by talking about shape generator. As you will see immediately, this kind of analysis offers the possibility to generate a part connected with how that part is under stress from forces, moments, pressure, etc. 5 years ago, I posted this project model named cork press. You'll see what is it about on the platform GrabCAD, and you can find it by using this link, grabcad.com library cork press 1. You see description of this project. It is very interesting and you have full access to open and to look at it. If necessary, you can create your own account to this platform, giving a name and a password. This is not a problem for anybody. Not only description is here, but also all the parts are present in this project, as well as comments about. Okay. More than this, you can download all the parts, not from here, although it's possible to take them from here, but directly from me, from this page. This is my own website, and you can access all the necessary parts which are not created in a tutorial. You can download them from here. For instance, today you can download this. After you download and unzip this file, you'll find all the parts and the assembly in your directory. Then you can open this assembly using Inventor, of course. This is what you will see. I want to show you how it works. Action arm is the part, and I created for you a constraint of an angle between two parts here, so that you can apply drive, and you start this to see what happens when you use this cork press. You manipulate this handle, and the cork is pressed into the bottle. Yes, this is very interesting and original, very original. I created this. I can patent the solution because it uses the Cardan law that tell us that let me find again a principle. This is a principle. In my words, given two circles where one has a double radius than the other, when the small circle rotates, sleepless interior tangent to the great and grounded circle, then a point, any point of the small circle, describes a diameter, that means a straight line of the great circle. This is very, very interesting, and I use it to create this project. You'll enjoy to see. So, when you use the handle, you move this rod, and the small circle is this one, and the other is this one. The small circle is half radius than the other. This is why these two rods are moving freely in their bearing. Yes? You see all the situation here, very, very nice. Okay, and where is frame generator? We discussed about frame generator. Well, there are some forces here, yes, and I want to change the shape of this part, the body of the cork press. I want to make this light. To make this by eliminating some parts of it because it is too heavy. Now it has, for you to know, 5.77 kilograms, and I think that we can go to, say, 2 kilograms by eliminating some parts of it. Let's see how can we do this. This is the body. Yes? This is the body, and if we try to understand what and how it is, we see three guiding bushes which can be welded on some plates. Yes, this is a possible solution for creating this body of the cork press. Good. The procedure is natural and relatively simple. Before to start it, I want to make visible this definition virtual elements to have them as reference for what we do next. You have this interesting image. Yes? Good. We use directly shape generator, a tool which send us to the analysis. What we do is to use shape generator from transforming or refining this part to this one, which is lighter than the first and still strong and resistant. Okay, let's see how to do this. First, you have to see the material. Okay, still carbon. Then we place the constraint fixed to the bottom of the body, and then force. We don't want to make great vectorial calculus here and other special idealization, how can I say, of the situation. We place a simple force here, but not a force placed on a face, because we don't have that face, but a remote force, which is defined by using a point location, a point like this one, and you see that the force, the vector is here in the origin, but oriented accordingly to this hole. And I calculated some elements. The remote post must be placed on Y at 340 millimeters and on Z at 220 millimeters. And then we go here more to more. You see the vector is here, and we use vector components to place the force. These components are 100 on Y and 40 watt, 40 newtons on Z. You see the vector is inside the part. You can place a vector anywhere by using this procedure. Yes, you use force, remote force, not force directly. Good. This is all about the external elements. Fix here and a force here. Good. Next thing to do is to indicate what parts of this large part must be preserved, which means not changed anyhow, and you use preserve region to show that regions of the part. For instance, you show this and you have suggestion, or you can show better this and you have what you need. I want to preserve this element of the body, not changed, not modified. Okay, apply. The other one is this cylinder, which is larger, I suppose, no, smaller, and I modify to be like the part. I can use dimensions here, but this is not so important. You will refine the procedure as you want. Apply. Another one is this. This is okay. Apply. All of this we don't want to be modified by the program. The last cylinder is this one, and it seems to be okay. You can modify the diameter, everything. Yes, you move this and you show to the program what to be preserved. And the last one is a rectangular, not cylindrical. Apply by showing this face, and I suppose that this is enough to be preserved. Okay, this was the third 1, 2, 3, the fourth moment of our procedure. Now we start the generation of the shape, but before I want to make some settings here and to tell you about them. As you can see, the part has the original mass of 5.77 kilograms. And we intend to modify this mass to decrease it, to make it lighter than here, reducing by 60%. In other words, to be 40% weight than now. This means 2.31 kilograms. No, we decided to be 2 kilograms. Yes, instead of 5.77 to be 2 kilograms. Now we choose the mesh resolution. If we choose a finer one, we obtain a more precise solution, but the time is longer. I will go to say 2. Expect a longer solve time, of course, than to be in the middle. Okay. The next step is to generate the shape. By using this tool, I launch Run, and I bring a clock here for you to see how long it needs. Oh, under 1 minute it was. Good. Let's go the clock outside, and now we have to see what is here. As you can see, I forgot to preserve these 2 holes, but this is not important, as you will see. You see the mesh, and you see for that force of 10 kilos. Yes, 10 kilos and a little, of this force. We now have to refine this solution, which is brute, which is not fine. But we have tools to do this. And the tool is promote shape. Yes, we activate this tool. We accept to place the mesh on the current part file. Okay. And the recommendation now is to, if we change the visual style to wireframe, we'll see another view. Firstly, let me make this not visible, and then we choose wireframe, and we see how this is. You see, very interesting for everybody. I go back to shade it with edges, and now I create my own shapes for every missing material here by using the coarse mesh. The best way is to create a sketch and to use lines like these ones, closed contours. I want to be near that target of 2 kilos. This is why I don't ignore the mesh. Here I make such a rectangle. Everything can be adjusted. Here I place an arc. Okay, I hope that's all. And now extrude. This, all of them through, cut through. Okay. Body not visible. Now we can add some fillets with radius 20. Not 20, but 14. I'm curious about the weight. Yes, we'll see what the weight it has. I place no any dimensions here, and this is not very nice, but this is rough work. The first result is this, and the body is 3 kilos. Yes, we can work to refine this, and I'll show you after some modification will apply. I'll apply. Wait for me to see that modifications. And this is a final solution for this entire shape. Now we can verify what is the weight of this new shape. 2.7 kilograms from 5.77. I see a good promotion for this body. You are free to make any changes because you can download the assembly. Coming now to the assembly, we can replace this old body with the new one. I saved it under the name body after. We can replace in place this component by using replace, selecting what replace, right click, continue, and body after. You see now the new face of this body. Of course, we have to change this ribs here, yes, but this is another problem. We are happy by having this elegant and fine assembly with a new lighter mass. Yes, try for yourself to make the same. I'll attach in the zip also this new shape of the body can make that replacement for yourself. Now we can say that Inventor is not only a parametrical and adaptive software, but also generative. This is a new and very interesting ability for modern technologies. Remember that Inventor has this ability since 2017. So when you use 3D printers to make parts, this is the proper way. That's enough for today. Bye-bye.